The Earth is flat, stationary, and enclosed by a glass dome known as the firmament, which contains the sun, moon, and stars, all of which move, not the Earth. Above and below are waters. But this isn't a conspiracy. It's an idea worth exploring. If satellites were really in space, why would we need communication towers in the middle of the ocean? A compass only functions properly on a flat surface to differentiate between north, east, south, and west. Water always stays level and contained, therefore the Arctic Circle and Antarctica act as natural barriers that hold the oceans in. The solid glass dome, or firmament, keeps the air inside, creating a sealed, airtight environment. We're told the Earth spins at millions of miles per hour like a ball, but does that align with observable phenomena? Thunder's booming sounds are produced when solid objects shift, hinting at a stationary, grounded world. Even world leaders seem to know this truth, as evidenced by the flat Earth map on the UN logo. Once again, it's the sun, moon, and stars that rotate from east to west, not the Earth. Therefore, the heliocentric model raises questions. The people who taught us that the Earth is a globe are fully aware of and believe in the flat, enclosed system we all live in, a system from which no one can leave. We're told that Earth spins at 1,000 miles per hour, orbits the Sun at 66,600 miles per hour, and chases the Sun through space at nearly 500,000 miles per hour. But if all this motion is happening, how can Polaris, the North Star, remain perfectly stationary in the night sky? Consider the Georgia Guidestones, which had a small hole drilled through one of the central stones. If you looked through that hole, you could always see Polaris perfectly aligned. Therefore, if Earth were moving in so many directions and traveling vast distances, Polaris should shift out of sight constantly. Yet it stayed perfectly in place for 40 years until the monument was destroyed. But let's dig deeper. Earth supposedly spins eastward at 1,600 kilometers per hour at the equator. Here's a question. How does a plane flying eastward at just 800 kilometers per hour ever reach its destination? Shouldn't the ground be moving too fast for the plane to catch up? And what about landing? Imagine trying to land a plane safely on a runway that's supposedly zipping along at 1,600 kilometers per hour. It sounds risky, doesn't it? The official explanation is that Earth's atmosphere is stuck to the planet, held by gravity despite the vacuum of space above. But if that's true, wouldn't pilots need to constantly adjust for Earth's curve? At 800 kilometers per hour, a plane would need to lower its nose by around 850 meters per minute to stay aligned with Earth's curvature. Therefore, without constant adjustments, the plane would rise higher and higher, reaching about 50,000 meters in just an hour. Yet pilots don't make these corrections.